Great day! My name is Arlene Jean Belgrado, VTVT and ELX2A. Today, I will discuss how the video signal generated. A video signal is usually generated by a video camera. The camera takes the scene and scans it electronically, dividing it into hundreds or even thousands of very thin horizontal lines. In order to convert them into electrical signal, the scene to be transmitted is collected and focused by lens upon the light-sensitive imaging devices. Both vacuum and semiconductor devices are used for converting the light information into an electrical signal. The scene is divided into smaller segments that can be transmitted serially over a period of time. The camera subdivides the scene in an orderly manner so that an acceptable signal is developed. This subdivision process is known as scanning. So scanning is a technique that divides a rectangular scene into individual lines. The standard TV scene dimensions have an aspect into ratio 4:3, that is, the scene width is 4 units for every 3 minutes of height. To create a picture, the scene is subdivided into many fine horizontal lines called scan lines. Each line represents a very narrow portion of light's variation in the scene. The greater the number of scan lines, the higher resolution and greater the detail that can be observed. The TV camera converts the scene into an electrical signal, transmitting a voltage of 1 volt for black and 0 volt for white. The electrical signal derived from each scan line are referred to as a video signal. Shades of gray are represented by some voltage level between 0 and 1 volt. Extremes represented by white and black. So the resulting signal is known the brightness or luminance signals is usually designated by Y. One complete scanning of the scene is called a field. The scene is scanned a second time in such a way that its scan lines fall between those of the first field. This produces what is known as interlace scanning. Interlace scanning is used to reduce flicker. The resolution of TV picture refers to the amount of detail that can be shown. Pictures with higher resolution have excellent definition. A picture lacking detail looks softer or somewhat out of focus. The bandwidth of a video system determines the resolution. The greater the bandwidth, the greater the amount of definition and detail. The color detail in the scene is represented by dividing the light in each scan line into 3 separated signals, each representing one of the 3 primary lights color, red, green, or blue. The light in any scene can also be divided into its 3 basic color components by passing the light through red, green, and blue filters. The result is the generation of the 3 simultaneous signals, RG and P, during the scanning process by the light sensitive imaging devices. The RG and B signals also contain the basic brightness or luminance information. The color signal must be transmitted with the luminance information on the same bandwidth allotted to the TV signal. This is done by the frequency division multiplexing technique that combines the three color signal into I and Q color signal. These signals comprises different proportion of the R, G, and B signals. I is equals to 60% red, 28% green, negative 32% is blue. So, Q is equals to 20% red and negative 52% green and then 31% blue. The I and Q signal are called chrominance signals. To transmit them, they are phase encoded. They modulate a subcarrier which is mixed by the luminance signals to form a complete video signal. The resulting signal is called the NTSC, Composite Video.